You know that feeling when you need to make a rectangular part in Delrin but you've only got round bar stock? Yeah, that feeling. Well, I think this could be a lot of fun. I'm making 6 antenna boom clamps for a pair of high performance 432 MHz long Yagi antennas. The brief is that they must be as transparent to UHF radio signals as possible, but survive 100 mph wind, icing and being sat on by fat birds. As usual, I fired up Fusion 360 and had a think. A less than auspicious choice of material perhaps, but it's what I've got. Those clamps are inside that bar somewhere.
Hey Neil, can I say we start by facing off as is tradition please?
Hi Amy, I think you just did. As regular viewers will know, Amy's my artificially intelligent machining and engineering expert system. Did I detect a slightly smug grin on her face there? Machining's easy. I just need to remove the bits of that Delrin cylinder that aren't spigots and saddles. Simples. I'm taking gentle cuts because of the large amount of stick out. It would be easy for the tool to grab and rip the workpiece clean out of the chuck, probably flinging it at a delicate part of my anatomy, or more importantly some vital piece of machinery. The spigot's the only critical dimension. It's got to be a firm push fit but not too firm, as there's a danger of splitting the thin walled GRP tube that fits over it. The difference between the tube falling off or being split is quite a fine balance, but I've measured this carefully and I repeat the same set of cut depths and chip loads for each spigot. There's no spring cuts or blank passes in this workshop. Here we obey the laws of physics. Balanced cuts on bendy materials and with bendy tools. In related news, all materials are bendy, so are all tools. I'm slightly surprised by how many proper YouTube machinists seem to treat tool and workpiece deflection as some sort of mystery and end up taking a second pass at the same diameter in the hope they might hit the target dimension, but then go too far, or not far enough, and then have to take suboptimal cuts to reach the final dimension. Perhaps it's all from hard experience in a time before digital readouts were in common use. I'm a rank beginner, not a proper machinist, so I just use science and logic and stuff and hit my dimensions by measuring actual outcomes.
Neil, you're such a noob. Also a nerd.
Spring cuts? Just say no. I'm lining up the offset for parting off by eye, zeroing the DRO, moving a millimetre or so extra, then plunging in with an insert parting blade with way too much stick out, and the wrong sort of insert for Delrin. Yeah, it might have been a prettier ribbon if I'd used a handcrafted and honed high-speed steel parting blade, but life's short, the sun's shining, and I'm okay with a bit of compromise. Occasionally. Haters gonna hate, but it works fine. I'm taking bets on how long it'll be before the first opinionated answer guy posts a sage comment like,
"You should have cleaned those dangerous ribbons before continuing. They represent a safety hazard. I hate you, you are a useless machinist."
Lather, rinse and repeat 6 times. With Delrin prices being ludicrously high, I'm not wasting the bar ends. The plan's to flip the part and chuck it on the machine surfaces, then machine it to diameter and length. If I calculated correctly, there should be just enough material to make 2 discs that I can then mill to size for the U-shaped saddle clamps. Fingers crossed, I'm notoriously bad at subtraction. Yikes, that's going to be a bit tight. Rather than trusting in mental subtraction, which is always a bear trap for me, I'm going to line up the front and back of the workpiece with the right and left of the parting tool and use the half button on the DRO to find the middle. I can do vector calculus and manipulate quaternions like a boss, but subtraction, just don't go there. Did I catch it? Did I fumble it and drop it into the dark inaccessible entrails of the cross slide to be found some decades hence by a confused future owner of the lathe when I'm long gone? Gentlemen don't discuss such matters in polite company. .40 microns undersized, which is well within my 0.5mm tolerance. I can be quite tolerant if I try hard. Time to make the threaded and slotted stainless inserts and spacers, so I'll swap to the ER40 collet chuck. That's a coated Corloy CCMT09T308 from Cutwell, intended for finishing cuts on stainless. It breaks nice chips on big material when you take deep cuts, but I'm looking for precision here rather than finish and cycle time. Expect some stringy chips. These blue ring spiral flute taps work nicely in 304 stainless. This is going to be one of the long inserts, so I've drilled it 16mm deep to make sure there's a full form thread over the finished 10mm length. . Next step's to turn the OD to 7.04mm. This is one of the longer inserts for the 40mm clamps. The others have the same M4x0.7 thread but are only 6mm long. Hey Amy, I've made 4 30mm clamps and 2 40s. The 40s each have 4 bolts, collars and threaded inserts. The 30s have only got 2 of each, but the collars are all identical. How many of each part do I need to make?
Why on earth are you asking me? Do you think I'm some sort of overclocked pocket calculator like Alexa, or something?
Well, can you at least make an estimate?
Oh good grief, if you insist. 6, 8, 2 twice, 16. Okay, the total comes to somewhere between 11 and 20.
Thanks, I think. It's somehow terribly un-British to ask, but if you feel able to click the like button, it makes the algorithm very happy. I also appreciate it enormously. One of my favourite things about machining is designing and making fixtures and jigs. This one's super simple but does its job to perfection. No fuss, no drama. The plan's to face off this bit of brass bar, then drill and tap an M4 thread and fit a long steel screw. I'll trim, face and chamfer that to about 5mm so I can use it to finish the parted off faces of the threaded stainless inserts. I snapped my only 3.4mm jobber drill yesterday, so I'm drilling this 3.30, which is a bit tight for brass. Ominous foreshadowing, as Quindunky doubtless would intone. Everyone tells me there's absolutely no need to use cutting lube on brass. Wish me luck, I'm going in. If any mansplaining answer guy keyboard warriors out there are tempted to tell me in block capitals that I'm using the wrong tap and should therefore burn for eternity in machinist hell, there's really no need. I already know, honestly. I'm not using Loctite as I expect I'll be changing the threaded bit regularly. A judicious amount of A-bomb torque should be sufficient. Perhaps a slightly unconventional use of a tailstock live centre, but it's 1:30 AM and I can't use the angle grinder without waking the entire village. The point fits nicely and it means I can part this off quietly. Observant listeners may notice a hugely subtle edit transition there after I swapped to a polished insert. That stainless one really wasn't happy. I've zeroed the DRO with the tool just kissing the face of the fixture so I can set the trim length. Super, that's umpty 3 of the long inserts finished, now for the roughly 12T short ones. Counting's really not my thing. This Edge Technology Precision Chuck Stop kit's brilliant. It's great for ensuring the back face of a part's parallel to the chuck face. It comes with several different precision parallels and it's magnetic. I'll try to remember to put a link in the description. Let's face off these Delrin pucks to the finished size ready for milling. As usual, I'm deploying the super high-tech contact detection shim system to set the zero position of the tool, remembering to add in a tad to allow for variances in contact pressure. Next step for these little hockey pucks is to square the circle, or rather to cuboid the cylinder. Somehow doesn't have the same ring to it though. Where have we got to with this project so far? In answer to my earlier question that Amy dodged so artfully, there are 16 of the 7x4 collars, 8 of the 6mm slotted threaded inserts and 8 of the 11mm versions. That's 16 screwdriver slots, 4 small, 2 large saddles, same for spigots and 16 bolts to shorten. Oh, and 6 anti-split collars. Part 2 will appear here quite soon, and YouTube thinks you might like that video too.